What are Python data types? Explain with examples. In programming, data types are a way of classifying the information that can be stored in a variable. This is important because the specific data type you use will determine what values you can assign to it and what you can do with it. Data stored in memory can be of many types. For example, a person's name is stored as a text type, age is stored as a numeric value, and their address is stored as alphanumeric characters. In this video we will explain the following data types. Numeric types include integers, int, floating point numbers, float, and complex numbers. Boolean types include the Boolean type, bool, which can take true or false values. Text types include strings, which are used to store and manipulate text. Collection types include lists, which are used to store and manipulate collections of elements. Introduction to int. The integer or int types in Python allow us to store a non-decimal numeric value, either positive or negative, of any size. The type function returns the type of the variable, and we can see that it is indeed of the class int. Unlike other programming languages, in Python there is no maximum value that can be represented by integers. Python takes care of allocating more or less memory to the number, and we can represent virtually any number. This means that we don't have to worry about integer size limits. In Python, when a decimal point number is assigned to an integer variable in Python, the decimal number will be truncated and only the integer part of the number will be stored. For example, if we assign the value 3.14 to an integer variable, the variable will store the value 3. In the previous example we have tried to assign a decimal number to an integer variable, but in Python we can represent numbers in different formats. For example, we can use the prefix 0b followed by a series of digits to represent a number in binary format, 0x to represent it in hexadecimal format and 0o to represent it in octal format. When we assign a number in any of these formats to a variable, Python will interpret and store it internally as an integer, int. However, when printing the value of the variable, Python will display it in decimal format. In this example, we assign the binary, hexadecimal, and octal values to 3 different variables and then print them to check that Python interprets them correctly. If you want to know more information about the different number formats that you can use, you can consult the official Python documentation that I will leave you in the first posted comment. There you will find detailed information about the different numeric types, how to perform operations with them, how to convert them from one type to another, as well as information about the different number representation formats, such as binary, octal, hexadecimal and scientific notation. Although as we have said, Python can represent almost any number, there are borderline cases in which we may encounter an exception like the one shown below. A curious case is that if we try to represent an even larger number, we will encounter the following instead of an exception. Float. The float type is a numeric data type used to represent real numbers, that is, numbers with decimal places. In Python, floats have double precision, meaning that they have twice the precision of single precision numeric types such as integers, int. When we assign a decimal value to a variable, Python automatically converts it to a float. We can also create a float using scientific notation with the letter e and the exponent. If we want to convert another data type to float, we can make use of the float function. For example, if we convert the Boolean value true to float, it becomes 1.0. It is important to keep in mind that floats do not have infinite precision. We can see in the following example how in reality a is stored as if it were 1, since it is not possible to represent so much decimal precision. Float range. Float numbers in Python have a limited range of values they can represent. The minimum value they can represent is, and the maximum is. This means that any value outside this range cannot be represented as a float. For example, if we try to assign a value greater than the maximum allowed to a variable, that variable will take the special value of infinity, inf. The same will happen if any operation is performed that results in an out-of-range value. In the example above, the variable maximo contains the maximum value allowed for a float, while the variable mayor_al_maximo contains a value greater than the maximum allowed, which causes it to take the special value of infinity when printed. It is also possible to directly create a variable with the value infinity using the float inf keyword, for example. In this way, we can create a variable that has a very high or very low value without worrying about the allowed range for float-type numbers. Complex numbers. The complex numeric type, complex, allows you to represent numbers that have a real part and an imaginary part. 1_real part, as for example 3 or 7.5. 2_imaginary part 5j or -7j. In mathematics, a complex number is represented in the form a, b, I, whereas the real part and b is the imaginary part which is represented by the letter I. In Python, the imaginary unit is written with the letter j. But what are complex numbers used for? Complex numbers are widely used in physics, mathematics, telecommunications, and electronics. A complex number can be represented on a plane, where the x-axis represents the real part and the y-axis represents the imaginary part. For example, the complex number 5,5i can be viewed as a point on a plane with coordinates 5, 5i. The graphical representation on a plane is very useful for understanding and manipulating data. To create a complex number in Python, the syntax of bj is used, where a and b are real numbers. For example, in this example, we have created a variable z containing the complex number 32j. When we print the variable, Python returns 32j, indicating that it is a complex number. Complex numbers in Python can be operated on in a similar way to real numbers. It is possible to add, subtract, multiply and divide complex numbers, and common mathematical functions, such as square root, can also be used. It is important to note that some operators, such as division, can generate complex results even when the original numbers are real. For example, in this case, we have divided the real number 10 by the real number 3, but the result is a complex number that includes an infinite decimal part. It is also possible to access the real and imaginary parts of a complex number using the attributes real and imag, respectively. For example, if you want to perform more operations with complex numbers, you may want to take a look at the CMath library, which is much more complete and complex. Booleans in Python. As in other programming languages, in Python there is the Boolean or bool type. It is a data type that allows storing two values true or false. A Boolean variable can be declared as follows. A Boolean value can be the result of evaluating an expression. Certain operators such as greater than, less than, or equal to return a bool value. They are also very useful in conditional expressions. They are used to make decisions based on whether a condition is met or not. For example, if we want to print a message only if a variable named x is greater than 5, we can use a conditional expression like this. In addition to the comparison operators, Python also offers the logical operators and, or, and not, which can be used to combine more complex Boolean expressions. For example, if we want to print a message only if x is greater than 5 and less than 10, we can use the following conditional expression. An important thing to add is that any value that can evaluate to true or false can be converted to a Boolean value. Values that evaluate to false are called falsy and values that evaluate to true are called truthy. Values that evaluate as falsy are false, none, 0, 0.0, empty quotes, data structures such as an empty list or empty dictionary. In this example, we have a variable containing an empty string, and when evaluated in a conditional expression, it will evaluate to false, resulting in, the string is empty. Python strings. Strings in Python are like a series of characters or letters used to store text. They are very useful for storing information such as names, addresses, messages, among others. Strings are an immutable data type, which means that once they are created, you cannot change the characters they contain. To create a string in Python, you need to enclose the text you want to store in double quotes or single quotes. For example, to create a string containing the text "Hello World," you can write it like this. Strings are not limited in size, so the only limit is your computer's memory. A situation that can often occur is when we want to insert a quotation mark, either single or double, inside a string. If we do it in the following way, we would have an error, since Python does not know very well where it begins and ends. To solve this problem, we must resort to escape sequences. In Python there are several of them, but we will analyze them in more detail in another chapter. For now, the most important one is \, which allows us to embed quotation marks inside a string. It is also possible to make a line break in the same line of code, and this is a special character used to indicate the end of a line of text and the beginning of a new one. In Python, it is represented by the escape sequence \n. A nice thing about this programming language is that when we want to define a string that is very long or takes up several lines, we can use triple quotes before and after the string. In addition, there is a way to declare strings called raw strings. To do this, we must use the letter R before the opening quotation mark. In this type of strings, Python will ignore all escape sequences, such as the line break, so the string will be printed as it was written, without interpreting these special characters. String formatting. String formatting is a technique for constructing more complex and expressive strings using placeholders that are then filled with specific values. In Python, string formatting is performed using the format method and the braces syntax to delimit placeholders. For example, suppose we want to create a string containing the name and age of a person. We could do this as follows. In this example, is a placeholder indicating where the name and age values should be placed. The format method is used to fill these placeholders with the specific name and age values. In addition, you can specify print formats for the values, such as the number of decimal places in a number or the width of a field. For example. But it is important to mention that if you have the updated version of Python, higher than version 3.6, you will notice that a new syntax for string formatting called fstrings has been introduced. This syntax is simpler and easier to read, and is based on placing a letter F before the string, followed by braces. Some of the methods of the string class. Capitalize. This method is applied on a string and returns it with its first letter capitalized. Lower. The lower method converts all alphabetic characters to lowercase. Swap case. The swap case method converts uppercase alphabetic characters to lowercase and vice versa. Upper. The upper method converts all alphabetic characters to uppercase. Count. The count method is used on text strings in Python and counts the number of times a character or substring appears in the main string. For example, if we have the string "Hello World" and we want to know how many times the letter O appears, we can use the count method as follows. Lists in Python. Lists in Python are a very useful data structure that allows you to store several elements together, be it numbers, strings, booleans, or even other lists. They are mutable and dynamic, which means that we can add, remove, and modify elements at any time. This is the main difference with sets and tuples. Lists in Python are one of the very versatile data types or structures of the language, since they allow us to store an arbitrary set of data. That is, we can store practically anything in them. If you come from other programming languages, you could say that they are similar to arrays. To create a list in Python, you simply enclose the elements you want to add in square brackets and separate the elements by commas. To access the elements of a list, we can use square brackets and an index ranging from 0 to n1, where n is the size of the list. For example, If we have a list fruits with the elements apple, banana and orange, we can access them as follows. We can also access the last element of the list using the index -1. Likewise, if we want to modify an element of the list, we can simply assign a new value to it with the equals operator. An element can be deleted with different methods as we will see below, with del or pop, but the latter returns that deleted element. We can also remove elements by their value, using the remove function. If we want to empty a list completely, we can use the clear function. As for nested lists, we can have one list inside another, which is known as nesting. To access the elements of a nested list, we simply use the bracket notation several times depending on the depth of the nested list. For example, in this example, we have a nested list 3 levels deep, so we use square brackets 3 times to access the value 4, which is in the third position of the third nested list within the main list. We can also create smaller sublists from a larger list in Python. To do this, we use square brackets and colons inside them. The number to the left of the colon indicates the index of the first item we want to include in the sublist, while the number to the right indicates the index of the first item we want to exclude from the sublist. In this case, the sublist contains the elements of index 1, which is number 2, and index 2, which is number 3, but does not include the end, which is the element of index 3, in this case it is number 4. Iterating lists. Iterating through a list in Python is a very common task in programming. To do this, you can use a for loop and the built-in range function to step through the list item by item. List methods. Append. The append method adds an element to the end of the list. Extend. The extend method allows adding a list to the initial list. Insert. The insert method adds an element at a given position or index. Reverse. The reverse method reverses the order of the list. Sort. The sort method sorts the elements from least to greatest by default. Index. The index method takes an object as a parameter and returns the index of its first occurrence. And that's it. In this video we've gone over the basic data types in Python, from numbers and strings to booleans and objects. We've also seen how to work with variables and operators to manipulate this data. Python has many more data types and data structures besides lists, but lists are a very powerful and useful tool in Python programming. I hope you found this video useful and that it helped you better understand Python data types and how to work with lists. Thanks for watching and see you next time.